Hi guys, so today we're going to start Unit 7. Unit 7 is going to continue what we've been doing with functions, but we're going to start looking at other types of functions. So right now we've looked at linear functions and quadratic functions, and now we're going to expand that and start looking at cubic, square root, and cube functions today, or in cube root functions today. So what I want you to do is go ahead and pause this video and take about 3 to 5 minutes and complete the opening exercise, and then when you're all done, hit play, and then we'll go over the answers together. So go ahead, pause the video right now. Alright, so hopefully you've already completed the first 4 problems here. So basically these are just evaluation problems. So all I want to do is evaluate x squared when x equals 7. So really what that means is you just need to plug in 7 into x squared. So it's going to become 7 squared, which would give me 49. So that's your answer for that one. The next one, the square root. So you're plugging in x equals 81 into square root of x. So that just means we're plugging in 81 for x. Take the square root of 81, you'll get 9. Next one, 5 is going to go in for x, so it's going to become 5 to the third. And that'll give you 125. And remember, this really means 5 times 5 times 5. To do this in your calculator, you would use this caret key here. So you would just hit 5, caret, 3, and hit enter, and that should give you 125. And then the last one you might not have gotten, but it's the cube root. So see how you have this little 3 up here? This is called an index, and that means it's going to be the cube root of some number. So whenever you don't have that little number, like up top here with number 2, that's called the square root. It really has a little index of 2. Since it's so common, we just don't write it. It's just called the square root, and we don't put the 2 there. But if any other roots you want to take, you have to put the number above. So you could have like the 4th root, which would have a 4 there, a 5th root, 6th root, and so on. And to understand what these roots mean, so let's look at the cube root of 27. What that's asking you is what number times what number times what number, or what number times itself 3 times equals 27. So the answer to that is going to be 3. So here's why. If I take 3 and I multiply it by itself 3 times 3 is 9, times 3 is 27. So the cube root means what number do you multiply by itself 3 times? 4th root, what number do you multiply it by itself 4 times to get whatever the number is underneath the root? Square root, it's what number do you multiply by itself twice to get that number underneath. So that's the meaning of a cube root. So we're going to actually look at the graphs of these different types of functions, but before we do that, I want to just make sure on the calculator you know how to get this cube root, or really any kind of root. So if you look above the caret key, kind of like above the x squared, we have the square root because those undo each other. The caret and what we call the nth root, so the nth root is if you hit control, yours would be gold on your calculator. If you hit control and then you hit the caret, that's going to get you the nth root. And if you go ahead and go into the calculate screen and you hit control, make sure it's cleared out, and then hit control caret, that'll get you this nth root. And basically what it'll look like on your calculator is it'll look like this. And what you would put in is whatever root you're taking. So in this case, you'd be taking the 3rd root. So you would enter 3, and then whatever number you're taking the cube root of. So in this case it was 27, hit enter, and you should get 3. So this key is kind of like the way to undo something that's being raised to a power, which is why it's right above that control, or it's the control key for the caret. So make sure you actually try that. Make sure you know how to get those roots, because in a minute when we go to graph, you're going to have to be able to do that. So let's go to the next page and actually start looking at these functions a little bit more in depth. So just a quick refresher, we've talked already about linear and quadratic functions. So just remember linear functions, so you add this to the top of your page. So linear functions we know are lines, right? So they're going to, have a positive slope, or they might have a negative slope. They could be horizontal. They can't be vertical though, because vertical wouldn't be a function because it wouldn't pass the vertical line test. And when we're talking about our equations or our functions that are linear, it's going to always be, our lines will always be in that form y equals mx plus b. So that's how we know if something is a linear function, because it's just going to have an x, and an x won't be raised to any power. It's just going to be an x. If it's a horizontal line like this one, that's kind of the exception. That's just going to be y equals some number, because the slope is 0, so you won't see the x, you'll just see the y-intercept, which is whatever number that's passing through. And then from there, we talked about quadratic functions. So quadratic functions, the difference between a quadratic function and a linear function is the equation itself is going to have an x squared in it, so y equals ax squared plus bx plus c. And the biggest thing is you know something's quadratic when you see that x squared. So linear is just going to be an x, quadratic is going to have an x squared, and the way that the graph looks is going to be of a parabola. So either opening upward or opening downward would be a quadratic function. So there's your equation for quadratic functions. So now what we're going to do is we're going to compare quadratic functions with square root functions. So we already know what a quadratic function looks like. It's either going to be a smiley face or a sad face depending on that leading coefficient. But now we're going to look at, well, the function that undoes squaring something, the square root function. So how does that compare to the graph of a quadratic, the graph of a parabola? So let's go ahead and we're going to fill in this table here. So the first thing I want you to do is, since we are trying to graph a parabola, so this is going to be your quadratic function because it's an x squared, we're going to want this to have symmetry. We want this to be a symmetric looking graph because remember, parabolas are symmetric. So I'm going to plot some negative points and I'm going to plot some positive points. So go ahead and let's use these x values here so we have some symmetry. So we're going to plot some negatives and some positives. And then we're going to simply just plug these into our calculator, just like what you did in the opening exercise. So if you square negative 2, you're going to get 4. Square negative 1, you get 1. Square 0, you get 0. Square 1, you get 1. Square 2, you get 4. Now remember, if you would have just done this in your calculator in the graphing section, you could have just entered this equation into f of x into the graph and then looked for where you saw symmetry. So this point right here is our vertex, because then you start to see the y values repeat. So you could have done that as well instead of just plugging them in without a calculator. So let's go ahead and plot those. So I'm going to keep that in blue since it's the same. So it'll be the points will correspond to the graph. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. I'm going to make sure that I try to make this look as curved as possible. And I'm going to go ahead and I'm going to label it. Make sure we get arrows on it because it will go on forever. And then let's move on to the next function here. So this is called the square root function because it's the square root of x. So this is the square root function. So to find some points here, just go into, there's really two ways you can do this. You can go into the graph section if you want and get a table. So enter this into f of x. And I would clear out this parabola so it's not confusing. I would just clear that out of your calculator and then go into the graph, enter this in, and then you can look at the table, Control T to get the table for these, or you can simply just plug these in. So it's really up to you, whatever you think is easier. So I'm going to think of it as just plugging it in. So I know that if I plug in the square root of negative 2, hopefully that doesn't sound right to you, because whenever you plug in the square root, or whenever you take the square root of a negative, you're going to get an error. And the reason why it's an error is because it's not going to end up being a real number. So your calculator will say something about a domain error or non-real answer, something along those lines. And it's because we talked about it briefly, but if you take the square root of a negative, it's going to be an imaginary number. So we're just going to, for right now, we're just going to say it's an error. We can't do it because we're graphing on the real number system. So if you take the square root of a negative, just kind of think of it as an error or does not exist, something along those lines, not a real answer. So same thing, when I take the square root of negative 1, you're going to result in an error, meaning you can't plot those points. So then if I plug in 0, take the square root of 0, that's just going to be 0. Square root of 1 will be 1. Square root of 2 is going to be irrational, so it's going to be a messy decimal, so 1.4142 something. And then what will work nice, though, because right now I don't have many points to plot. Like if I plot those points, I have 0, 0, I have 1, 1, and I have 2, 1.4 something. So that doesn't really tell me much about what the graph's going to look like. So think about some points that would work out nice. Anytime I have a perfect square, I take the square root of it, I'm going to get a nice whole number. So if I take the square root of 4, so if I add 4 to my list, take the square root of 4, you're going to get 2, so that's a nice one. Next point that'll actually fit on this graph is if we take the square root of 9, that would be 3, so 9, 3. And that's it, that's all it's going to fit on here. The next nice point to plot would be 16, 4, then 25, 5, but those aren't going to fit. So if you haven't already entered this into your graphing calculator, go ahead and do that because I just want you to see what it looks like. It's going to end up looking like a partial parabola. So it's going to start at 0, 0. So if you graph this into your calculator, you can clear out the blue graph if you have it, and just graph this into your calculator. You should see that it starts at 0, 0, and it just keeps on continuing to the right, and it gradually increases. But really, it almost has a curved look like part of this parabola is really what it is. It's basically the reflection of y equals x squared. The positive portion of it, it's the reflection of that over this diagonal line y equals x. And that's something that you'll talk about later on in Algebra 2, but that's really where it's coming from. This part here, we can't reflect and have down here, because if you had this U shape continuing, then it wouldn't be a function anymore. And also, we only want the positive values of this when we reflect it. Because when you take the square root of a number, you're never going to get out a negative number. So that's why also it wouldn't be down here. So those are the graphs of our function. So let me add this label. And I'm going to actually label the axes too because I haven't done that yet. But when we look at this, remember it's an endpoint at 0, 0 because you can't have any negative numbers. You can't take the square root of a negative number. And it's going to keep on going to the right, though, forever, because you can take the square root of any positive number you want. It might not be a rational number, but that's okay. You can still do it, so you can still have a graph. So now, based on those graphs, let's actually answer some questions about that. So observe both columns from the table above. What do you notice about the values in the two columns? So when you're looking at these, hopefully you see some similarities right here. I see that I have some common points, and if you look at the graph, they intersect at those two common points. So both graphs have 0, 0 and 1, 1 as coordinates. So hopefully you kind of see some relationship there. You might also notice that like you have some similarities here. So in this column, you have x is 2, y is 4, but it's switched down here. So we have 2, 4, and 1 in the blue quadratic equation and 4, 2 in the square root. That's because when you square x or 2, you get 4. And when you square root 4, you get 2. It's because the functions cancel each other out. They're inverses of each other. They undo each other. So maybe that's something too. So let's say y equals x squared has 2, 4. And y equals the square root of x has 4, 2 as a point. So they have the x's and y's switched because they're inverses of each other. And that's really why these are showing up twice, is because when you square 0, you get 0. And if you square root 0, you get 0. If you square 1, you get 1. If you square root 1, you get 1. And I believe that was one of the questions down here further. why do they intersect at 0, 0, and 1, 1? And that's because, so I'm going to just go ahead and jump down and answer that since I just talked about it, and then we'll go back. So why do they intersect at 0, 0, and 1, 1? Because if you square 0, you get 0. And if you square root 0, you get 0. So since it's you plug 0 into one function, you get 0, and you plug it into the other function, you get 0, it's a common point between both equations. So 0, 0 and 1, 1 satisfy both equations is another way to look at it. And then I'm just going to say, and this is the same for 1, 1. So really, too, it's because there's solutions to both equations. And this is why. This is like the writing out of why there's solutions to both equations. So then let's go and look at these other questions here. So for this one here, why are all y values for y equals x squared positive? Well, whenever you multiply two negatives, so when we plugged in a negative number, that really means a negative times a negative, which is a positive. So that's whenever you square a negative, it's always going to be positive because you're multiplying a negative times a negative, which is a positive. And if you plug in a positive, that's multiplying a positive times a positive, which is always positive. So whenever you square a number, it's always going to be positive. So why are all y values for y equals x squared positive? Because when you square a number, it will always be positive. And that's because, like I said, a negative times a negative equals positive, and a positive times a positive equals positive. So it doesn't really matter if you started with two negatives or two positives, because when you're squaring, you got to multiply the number by itself. So you'll never have a situation where it will be a positive times a negative. And why do we get an error for when we plug in a negative number into the square root? That's because you can't take the square root of a negative number. It's not in the domain. So you'll get what we call an imaginary number. So let's see. Produce an error for y equals the square root of x because you get an imaginary number. Which is a non-real number. And then the next thing is we want to look at the domain and we want to look at the range. So the domain, remember, are the x values. And then the range are the y values. So the first one, let's look at our parabola. So when we're looking at y equals x squared, the domain, so let's look. It has arrows on both sides, so eventually, if I'm looking at the x values, I can plug in any x value and I'll always get a y value. So the domain for y equals x squared is going to be all real numbers. It'll always exist. So the domain for this will be negative infinity to positive infinity, where if we look at y equals the square root of x, we will never include negative numbers, because remember, if you plug in negative numbers for x, you got errors. So that means the smallest x value, where it starts, is at 0, but it'll always include all the positive numbers. So this is going to be a square bracket around 0, because we include 0, all the way to positive infinity. And then for the range, so we'll look at y equals x squared first. So if I look at this parabola, I'm never going to have any negative numbers. So it's starting at 0 and it's going to go on to infinity. So it's going to be a square bracket at 0 going to positive infinity. And then we'll look at the other graph. So same thing with y equals the square root of x. It's going to start at 0 and it's going to keep on growing. Now it kind of looks like it levels off, but it's really going to keep on increasing up. It just looks flat, but it's going to slowly increase. So it'll slowly include all positive numbers. So again, the range is going to be from 0 to infinity. And any additional observations? I'm going to let you guys, again, pause the video and add anything that you want to add for that. That's completely up to you. If there's anything else that you think is worth adding, go ahead and do that. Pause the video to do that, and then when you're ready, press play again, and we'll move on to the next page. So go ahead, pause the video. Alright, so now that hopefully you've finished up that last example, so I'm just leaving that up to you. I know everyone's going to have a different answer for that. And what I want to look at together then is, to finish this up, I want to look at cubic and cube root functions. So those are going to be the functions that are going to undo each other as well. So when I say cubic, that means raising something to the third power. And cube root is going to be taking that cube root of a function. And these are inverses of each other. They undo each other. So if I cube a number, let's say I cube 3, I get 27. If I cube root 27, I'll get 3. So let's look at plotting these. So for this, again, I recommend doing this two ways. First, we're going to just evaluate these numbers, and then I would like you to enter them in your calculator so you can see what those look like. So for the first one here, this is going to be our cubic function because you're cubing the number. So it's an x to the third. That's how you know it's a cubic, where a quadratic is an x to the second, linear is just an x. And in your calculator, you're just going to use that caret key. So make sure that you put these numbers in parentheses, just like when you square a number. Your calculator needs to know that you really want to do -8 times -8 times -8. So it's that whole quantity in parentheses. So when you multiply -8 times -8, it's going to give you positive 64. But when you multiply that by another -8, it's going to end up giving you a negative number, and you're going to get -512. When you cube it, you should get the same answer. So when you put this in parentheses and you raise it to the third power, you should get -512. So try that in your calculator to make sure you are getting that. Then we're going to enter -2 in parentheses and cube that. That's going to give you -8. -1 cubed is going to give you -1. 0 give you 0. 1 cubed is 1. 2 cubed is 8. 8 cubed is 512. When we cube root these, so this is going to be your cube root function. You're going to use that control key and then hit the caret to get the, what we're going to call the nth root key, meaning you can switch whatever root you want. And then remember, in your calculate screen, when you enter this, whatever number you enter here, you always want to make sure that you put a 3 up there as the index number. So let's go ahead and get those, and then we'll graph them. So cube root, make sure that you put -8 under here. It's going to end up being -2. Because it's asking you, what do you have to multiply by itself 3 times to get -8? Well, the answer is -2, which is why, if you look right here, if you raise -2 to the third power, you get -8. So they undo each other. Next one, if I take the cube root of -2, you're going to get a decimal for this, so -1.26 is what I got. That's because you'd have to multiply -1.26 something by itself 3 times to get -2. It doesn't come out to a nice rational number. Next one, -1, 0, we get 1, 1.26, and we have 2 as the last one. So again, you see some similarities in the table, so we'll talk about that in a minute, but for right now, let's plot these points and look at what the graphs look like. So for the first one, I'm going to do in red, -8, 5, 12. I just know that it's just going to go -5, 12. It's just going to be way down here somewhere. So I just know that my graph's going to continue down there. I'm not going to worry about trying to graph -5, 12. I am going to do -2, -8 though. -1, -1, 0, 0, 1, 1, 2, 8, and we have 8, 5, 12, so way up here. So basically this graph is going to kind of have like a curve shape right here to it, and it's just going to keep on going up. So I'm almost not going to worry about trying to graph that last point, just because before it gets to -8, it's got to go way down. So it's going to look something like this. So let's go ahead and label that y equals x to the third. And this part here almost is more straight up, because it's going to take a while, like I said, to ever reach over to +8 to hit 5, 12. So there's that one. The next one, we have -8, -2. We have -2, -1.6, so you're going to kind of eyeball that one. -1, -1, 0, 0, 1, 1, 2, 1.26, so I'm just reading these points, and then 8, 2. So this one is going to still be increasing, but definitely at a slower rate here. So I have y equals 3, or cube root of x. And again, I should label my axes. So when you look at this graph, almost imagine if you were to fold along this diagonal right here, you should hopefully see that the graphs would actually match up to each other. So like this section here would come down and match up with this. This would fold and match up with that. And that's because these graphs are inverses of each other. So if you reflect one over this line, y equals x, which is what I talked about with the square root function, they would match up. So it's really, when I say reflect over y equals x, thinking about folding the square graph in half right along that diagonal, and they should match up. Same thing with this last page. If you were to fold along this diagonal right here, the line y equals x, this portion would match up with this. We don't map this section of the graph because then it wouldn't be a function anymore, and we can't ever have negative values when you square root something. So that's an important idea, and like I said earlier, you'll learn more about that when you get to Algebra 2. So what I do want to look at, though, is the domain and range of these and answer some of these questions. So the domain and range, let me start with the red graph here. So I'm going to start with y equals x to the third. So we'll look at the domain, then we'll look at the range. So the domain of x to the third, there's arrows on it. So it's going to always keep getting wider and wider. It's going to look like it takes a long time to get all these x values, but they're all included. Because you got to remember, 8, 5, 12 is a point. It's just you can't see it because it's not going to grow that wide that quickly. So -infinity to +infinity for our domain here. It's going to include all real numbers. Our range, well, it's always going to go down forever. It's always going to go up forever. So we're going to include all real values there as well. And then for the next graph, y equals the cube root. This is going to have domain, range. This one, I think it's easier to see that the domain is all real numbers because it's really, the arrows are going to the right and to the left forever. So it's easy to see that it'll stretch across the whole graph. So this is definitely going to be -infinity to +infinity. And for this one, I think the range is more difficult to see, but it's kind of like how the other one, it was harder to see that it's going to keep growing wider. This is going to keep growing taller and keep going down below. So eventually this is going to go on forever, both in the positive direction and in the negative direction. So your range will include all values as well. So -infinity to +infinity for that. And then for these other questions, How are the graphs related to each other? Well, they're inverses of each other. So they're inverses of each other. One function undoes the other function. I don't know if that's a word, undoes, so I'm going to put it in quotes. Undoes the other function. Meaning, if I take 3 cubed, I get 27. If I plug it into the first function in red, take 3, plug it into the first function, you get 27. Take 27, plug it into the second function, which is a cube root, and you get 3. So they undo each other in that way. Also, something that's worth noting is that they're reflections of each other, or they're symmetric over the line y equals x. So if I draw in this line, remember, like I said, if you were to fold along this diagonal right here, that line, imagine folding along it, the lines are going to be reflected. If you take one, reflected over it, it would map onto the other, meaning they're symmetric over that line. So I'm going to add that. So let me label this line so you know what I'm talking about down here. So I just go corner to corner for that y equals x. So I'm going to say the graphs are symmetric over the line y equals x. So that's that line right there, y equals x, if you didn't get the label. And then this question on here, describe the symmetry. Well, that's kind of one thing you could add to it. But another thing is in the table, you see, again, that symmetry where for the cube root, you have -8, -2, but for cubing, you have -2, -8. So you have the opposites, or the x's and y's are switched. So we have -8, -2, and -2, -8 are points in the among the two tables, as well as 8, 2 and 2, 8. So this is in y equals x to the third. This is in y equals a cube root. So the x's and y's are switched. And that's because they undo each other. So again, that's another conclusion you can make down here. Same idea. We also see that 0, 0, and 1, 1, and -1, -1 are all points. So see how we have that again? And that's because if you cube -1, you get -1. If you cube root -1, you get -1. Same thing with 0. Cube 0, you get 0. Cube root 0, you get 0. Cube 3, or cube 1, you get 1. Cube root it, you get 1 again. So that's why those are in both tables, because of the fact that if you plug in 0, 1, and -1 into both of these, you get the same answer. Because if we plug 0, 1, -1 into either function, we get the same answer. So now what I want you guys to do is, if there's any other conclusions that you want to add, because these questions are, I mean, there's multiple conclusions you can make. Here's just some of them. But if there's anything else you guys want to add, go ahead and do that. And then when you flip the page, there's a summary for you guys just to read through, the lesson summary. So you're going to read through that. And then the very last page in this packet is an exit ticket. So you're going to take about 5 minutes to complete that exit ticket after you're done with the video. So And you'll want to do that probably when you come back from break. So you're going to read the summary, do the exit ticket, so just detach the exit ticket right from the packet. Make sure your name's on it. After it's complete, turn that in, and then you guys will start the graphing classwork. And that'll be it for today. Have a good rest of the day, guys.